before starting, you have to make sure that the car file and the map file are in the same directory as that of the Python file. So just you have to make sure that this PNG file and this map file are in the same folder. That's it. First of all, import Pygame. Then Pygame. This initializes all the function, and then we have to make a window. Pygame dot display dot set name, and we don't know the dimensions. Let's say 0, 0 as of now. Pygame dot image dot load, and within single inverted we have to write the map, and as we can see the dimensions of the map are 713 and 409. So if we want this map to be completely in this window, so the window's dimension and map's dimension should coincide. So we can set 713, 713 and 409, and then to load the car we can use the same car.png. So next, inside a while loop, so as of now we are making it true. Display dot update. This will update the code and display in the window. So basically what we have done is we have used the BLIT, block image transfer, and as of now we have run a while loop which is true all the time, and when this condition is satisfied, that is all throughout, this will load the map and this will load the car at the position 0, 0. So basically in Pygame, unlike normal Cartesian coordinates, in the downside the y-axis is positive, and similar like and the x coordinates are always positive like Cartesian. The thing to note is in Pygame the y direction downwards is positive and not negative like Cartesian. So if we run this, yeah, we can see that we can see our map and the car, but the problem is that this car is quite large according to the map, and also this is not oriented with the road, like it should be rotated 90-degree in clockwise direction, and also its size has to be smaller. So let's use car equals to Pygame dot transform dot scale, So let's see if it works. But we have to make it even smaller. So let's say 30 and 50. This looks fine. So now we have to position it in the white road. So for that, instead of the 0 0, we have to make some coordinates like let's say 40 and 80 over here, 300. It has to be further below. Okay, that works fine. Now we have to rotate it. So car equals to pygame dot transform dot rotate, and the car has to be rotated by 90-degree clockwise. So let's say. So now we have fixed the car in the proper position. Now what we have to do is we have to increment its x value. Let's see. So before that, this car, this uh, this has to be variable, because the car, as the car will move, its x coordinate and its y coordinate will also move. So let's initialize another variable, car x equals to 40 and car y as 329, and let's put this values over here. And now we say car x, so the x value has to be incremented by 2. So let's see how it works. So as we can see, it is moving quite fast. If we want to control its speed, we can write log equals to pygame dot time dot clock, and inside the while loop we write clock dot tick 10. Now let's run it. So it is running quite slow. So let's increase it to, let's say, 90 or 50. This looks fine. So like if we see what happens, what is the basic logic is that as the car will see in the right direction there is black, so it will read 0. As it will read 0 in the right direction, it will have to take some decisions. And let's say in this position the car is running right here, and in the right it sees that pixel is black. So basically black corresponds to 0 and white corresponds to 255. So it sees that the black pixel is 0 and it cannot move in the right direction, but it sees that in the top direction there are white pixels. So what is expected from our car is it will rotate by 90 degrees and it will run in the plus direction. And as I have said, the coordinates in Pygame are different as that of Cartesian. So upward means the y coordinate will decrease. So basically, to see all these things happening, we need a camera also. Wait a second, getting. So let's make a camera. So we can make a camera like Pygame dot. We will draw a circle This circle will actually correspond to the camera in the window, and for the color it is RGB. So 0, 255, 250. So this will actually make a green circle, and this is the origin of the circle, and then we have the radius, and this will be the width. Let's run it. So as we can see in the corner in 00, we have created a green circle. So what we want is, we want to position the camera exactly at the center of the car. So let's do it. So similarly, as we had made the coordinates for the car, let's make it for the camera. CamX, Camboy. So let's put this CamX and Camboy in the origin. Now let's see. So we want the camera also to move with the car. So we need to position this in the while loop. Now let's run the program. So now as we can see, the camera is moving along with the car. Now the next thing we need to do is, we want to read the values by the camera. So let's write here. So let's make a variable window dot get at, and then we will print this right pixel. So let's run the program. Okay, so we are facing an issue because Like what is happening is this camera is actually fixed somewhere below or above the white line, so every time it is reading black. So what we can eliminate this error by making a variable, let's say focal distance, focal, and let's initialize it to 80, and let's say camera plus focal. Now let's run it. Okay. Still we are getting some error. So this also has to be fixed by hit and try. Okay. So it is reading fine, but still let's decrease it further. And okay. Now we can see as you can see it is reading 255 in the. Let's run it again. In white it is reading 255, in black it is reading 0, in white 255, and again it is reading 0. So it is fine. Now one thing we need to do is we cannot access this cross over here. So to access this, let's make this conditional. Initially we initialize the drive as true. Then let's say for every event in again dot event dot get, and if conditional, if event then here we can change the drive which was initially set to true. We can make it as update it as false. So now let's run it. Okay, there is some issue I guess. Okay, so we have to remove the parenthesis, and now it looks fine. Okay, now it looks fine and it reads the value perfectly, and we can access this cross as well. We want our camera to read all the directions, so let's copy it. So this will be up pixel and this will be down pixel. So to look at the up, uh, we have to make some changes in this window.get at, and we have to look up, so the y coordinate has to be decreased. So let's say cap y minus focal, and for the down we need cap y plus focal. Then to print this, up pixel and down pixel. So this will print all the three values. So So as of now only one value is being printed. So now we can say that our camera can look in all the directions. Let's run it. As we can see, it is reading perfectly. So now let's write the code for the car to rotate at the also we need to know that like at present in which direction the car is moving. So let's make a variable called direction equals to, and let's say the initial direction we have made to right, and this direction has to be changed when the car rotates either in up or down and or left or right, whichever way. So this variable has to be changed. So we write a if conditional if direction is right, and right pixel is not equals to 255, and a pixel is equals to 255. Then what we need to do is we need to change the direction as up, and then we have to do is we have to rotate it, and we need to rotate is uh, anti-clockwise by 90 degrees. So let's run this. Okay, so we have an issue with our code. Basically, as the car rotates, this camera also has to be rotated, and as we can see, the camera is not being maintained at the center. So for that, let's initialize the offset values for x and y of the camera. So in this for loop, we need to change uh, let's run the code. Okay, so y camera is perfect, but it is exceeding in the x direction. So let's write cam y offset is 0 and cam x offset we have to decrease it. So it is a random value minus 19. Let's see if it works. And okay, that didn't work because we haven't included it. Cam x offset. Offset. Now let's see. Okay, So now the camera is perfectly aligned, and we have to change this code. Car plus equals to. We have to make it a condition. As of now, it is running every time the code runs. So what we need to do is, if direction is right and right pixel is equals to 255, only then the car will run. If this condition is not satisfied, then the car won't run. Okay, so we have managed it perfectly. In this junction, as it says this is not equals to 255, it rotates. Here also we have to make changes for the car x new coordinates as it turns. So let's say the new coordinates are 26. Okay, so this is perfectly fine. Let's decrease it once. That is also fine. Okay, so this has to be somewhere around 20 to 30. Further, 26 is perfect, I guess. Okay, so we need to add more conditions. This is only a single condition. We can see there are multiple paths, so we need to add more conditions. So in the similar fashion, I have added all the other codes with Elif, and let me explain any one of them, that all these commands are almost same. So uh, basically this if, Elif, these four are for directions, and below this three are for the drive. I have written here drive for drive. Like if the direction, initial direction is right and the right pixel corresponds to 55, like it is white, then the x coordinate will be incremented by 2, and else if the direction is towards up and the upward pixel is 255, then the y coordinate will be decreased. Uh, as I had said, yeah, the coordinates of y are inverted in pygame. And another condition, if the direction of the car is in downward direction and the downward pixel corresponds to 255, then the y coordinate will be incremented. And let's run it. So as we can see, the car is moving perfectly fine. So like some values like this offset, I had to write it by hit and trial, because every time we need that uh, the camera corresponds to the center of the car, so it can see in all directions. And also what we have to do is we have to uh, dynamically change the car x coordinates. Like here it is plus 25 and here it is plus equals to 20. So these are all random values, that we have to make by hit and trial. So the main code is this direction one and this drive one. And to summarize, if we go from the starting, we imported Pygame, we initialize it, then we made a display, and then we let's stop this program. Okay. So we imported the map and the car image, then the dimensions of map we put it here as the window and map will have same dimensions. Then we scaled the car, then we rotated the car, then we initialized the car's initial x and y coordinates. So later on, what we did was we made the x and y offset for the camera, as we saw that the camera x and y were not always in the center of the car. So we had to introduce x and y offset and focal distance. Focal distance is nothing but it is a distance to which our car can see. Like why we introduced it was, like if our car is here, it will see 20, 20 units more, and it will see that there is black pixel. So uh, beforehand it will rotate. We don't want our car to crash over here. So that's the reason why we have introduced focal, and this is a direction. We have to initialize our direction, like the car has to know initially in which direction it is moving and in which direction it should move. Then we introduced a clock variable that will uh, basically control the speed of the car. So basically if we make this 200 and we run it, we can see that our car is moving very fast. Let's make it further fast. 999. So the car is quite fast. So in real life, as we have to send the signals to the Arduino and its processing speed is not that high, so we have to decrease it, and it works fine with 60 to 90. So we made a while conditional, while drive, and uh, the reason why we have put this is, like if at any time I want to press this cross, then it stops. Then this whole code terminates, and then we made our camera's origin. So initially this was we calculated 35 and 15 from hit and trial, and these three lines are for the camera to know to read the right, up and down pixels, and here we can print these conditions, these variables, and as I already explained, these are the if conditions. And this as I have already explained, this is BLIT. We are setting the map as 0, 0, and this car is dynamically being moved by this x and y coordinates, and we are changing in this if and else if conditions the car's x and y coordinates. And this was our camera, and every time we change something we have to update in the Pygame. So in the next video I will integrate this code with Arduino or ESP maybe. So there we can see the real life implementation of this car and how this will work in real life.